All right, welcome. I'm going to go over some R code that might be useful for working with indicator variables and working with homework number 3. So I've got the working directory set here, or I can just click on run and get that set. I'm going to read in a data set here, which is actually fairly large, and so I'm going to actually take a subset of it. Right, the data set has lots of variables and lots of observations. You can see that perhaps over here. And I don't really want to work with that many variables. And so I'm going to just make a subset right here. So I'm going to take the first 100 rows, 100 observations, and I'm going to just look at 3 variables. So got that there. And I'm just going to get a 5-number summary. And I can see I've got y, x1, x2, and I can take a look at some things there. All right, so in this assignment, this homework that you're working with, presumably while you're watching this video, is you're going to use an indicator variable. So what is an indicator variable? It's a variable that takes on a value of 0 or 1. And your data set might already have an indicator in there. There might be one that you have to create. You might have to create it from a character variable, or you could even create one from a numeric variable. So in this case, let's just take x1 and let's look at the median down here and the mean, right? So 9.9, 9.98, or 9.95 for the median here and the mean down there. So let's think about observations that have large values for x1. So those would have values, let's say, larger than 9.95 or 9.98, something like that. Let's just call it 10 to make this a little simple. So I'm going to create a variable. TR is the name of the data set. I'm going to call this ind for indicator. And I'm going to use the if-else statement to create an indicator. So if-else takes the first argument inside the parentheses and looks at whether or not that is true or false. And so what is the condition that I'm going to have here? It's this variable x1. And I'm going to simply ask, is it larger than 10? Right? That's about the mean or median. It's a little more, but. And so if it is large, I want it to take on a value of 1. So I type 1. And if it is not large, not greater than 10, I want it to be 0. So I'll get a list of 0s and 1s here. And I can just do that. And there we go. Now, I'm going to look at the data and see if this populated the way that I was hoping it would. So let's just look at the first few observations here. May need to look at a little more, but let's just try and give this a check first. So what do I have here? I've got this indicator is 0. x1 is less than 10. The indicator is 1. x1 is greater than 10. Indicator is 1. x1 is greater than 10. So it looks like it worked the way I was hoping it would. Okay, I haven't verified that for all observations, but I think R is working correctly and did what I thought it would do. Okay, so now I want to make a box plot, and I want to do that by levels, the levels of this indicator. So I'm just going to say box plot, and I could start with just the y, and that would make a box plot of this y variable. But what I want to do here is separate it out and have one box plot for when the indicator variable is 0, and one box plot for when the indicator variable is 1. So I'm just going to say tilde, and then tr, and here I'm going to use the indicator variable, so ind, and see what this gives me. Now, actually, let me just make sure. I've been goofing around in R outside of this video, so let me just make sure that it's just going to show me one panel, so just to make this a little easier. And so I can come over here in this spot here, and I can see what it looks like for the indicator is 0 and the indicator is 1, and I can see that they look fairly similar, except that for the indicator being 0, it has more, let's say, values outside of that interquartile range. But eyeballing it, these things look fairly similar, not identical, of course, but fairly similar, except for these whiskers are longer for the case where the indicator is 0. So got that. Then I just want to run a regression. And here, I think first I'm just going to run a regression without the indicator. So y is x1 plus x2, data is tr. And maybe I can get the summary out for that. And then maybe I can also plot it. Perhaps I want to see that. Maybe I'll see that a little later, but that might be something I want to do. So maybe I'm going to have a plot there in a moment, but I've just got my model here. Let's go and run that. And maybe I get a summary out for it. So it looks like x2 is statistically significant. x1 has a higher p-value, not statistically significant. But maybe what I want to do here next, at least thinking about what the homework might be, I want to get a predicted value. Let's just choose something. So I'm going to say predict, and I'm going to put in the model. So that's M. I called it M. And I want some new data. Well, so I'm just saying data frame. And I'm going to tell it what a value for x1 is. x1 might be, oh, let's just say somewhere near the mean. I think the mean was around 10, a little less, but let's just say 9. And maybe for x2, we could go back and look. In fact, let's go ahead and just do that for a sec here. x2, the mean was 12, median around a little over 12. Let's just make this one though 11. That's more around the first quartile. Let's just pick something there. And we're going to get out a predicted value. So we can just run this and get that out. With this function here, predict, you can also get intervals. You could get a confidence interval. You get a prediction interval for the y hat. Right? So that's the idea there. But I'll let you look into that separately. You can check that out. It says check for influential observation or observations. So here, maybe I just want to plot the model. You could specifically ask for Cook's D or D fits, but let's just get a plot out. And I think I ran that before. Let's just click on run. And I come over here and look, and there aren't any observations with large values for Cook's D. Let's though take just a minute here and create one, just so you can see what that would look like. Although I know you've seen it before, but let's just make a separate data set and let's make an influential observation so you get to see that. So let's just make TR2, and that's going to equal TR. So I'm just copying the data set TR to make a TR2 data set. So it's just a straight copy. Now what I want to do is create an influential observation. So I'm going to do that TR2, and I'm going to tell it a specific observation. Let's make it observation 50 right in the middle, if you will, since there are 100 observations here. And I'm going to make it take on a different value for variable 2, the second column, which happens to be x1, right? So in this slot right here, comma, and I've got the number here, 1 would be the first variable, 2 would be the second variable, 3 is the third variable. So 2 is the second variable, which if we come back up here, see the way that it's reading things, y is the first, x1 is the second, x2 is the third, so the second variable is x1. So it's going to be a value for x1. And what do I want that value to be? Well, if I make it somewhere between, let's say 6.9 and 12.4, that's not going to be very interesting. It's going to have leverage that's fairly standard or consistent with the other values. So let's make it something unusual. Let's say 20. That's quite a bit more than the maximum. So this would be the new maximum. So let's just do that. And then let's go ahead and going to run a regression. So I'm going to call this M2, and I'm going to just copy from up above. So I'm going to just copy paste here. Right, so linear model, but now I'm going to have TR2, this data set. So just run that. And now I'm going to plot M2 out. And what am I expecting to see down here in the bottom right corner where it's got the residuals versus the leverage? I'm expecting to see now something that might have large Cook's distance value, highly influential observation, and I'm expecting it to be observation number 50, because I'm just telling that there. So let's go ahead and just check. And sure enough, now this plot is quite different, right? And it's got one observation here. Might be hard to see on your screen there. It looks kind of small, but it is observation 50, and it's out there with high leverage, but also fairly large. Actually, eyeballing that, it's not particularly large on the Cook's distance. It isn't quite so large. Maybe let's go ahead and just make it even bigger, see if we can get it to be a large Cook's distance. It looks at this stage like it's high leverage, but not influential. So let's just make this even bigger. Let's go crazy here. Make this 40. So let's just run that, fix that. And now, lo and behold, yes, it is out there larger than 1 for Cook's D, and definitely high leverage and influential. Okay, just so you get an idea. Again, I know you've seen this before, but I'd have it there. All right, so now we want to add the indicator variable. So let's go ahead and make a new model. M3 equals linear model Y on X1 and X2 plus, we called it IND, and data equals TR. Let's run that. And maybe we want to look at the, well, maybe we'll look at the summary in a minute. Let's go ahead and get a predicted value. So here, I'm just going to copy paste. I'm not going to reinvent this wheel. I'm just going to copy this and down here. And so I've got these same values for X1 and X2, but now I've got something else that needs to go in here. I need IND. And if I'm putting this in this way, which is what I'm doing right now, I need to think, what value is that IND variable going to be? It's either going to be 0 or 1. Well, the way I defined it up above, which I can go back and check, is that if X1 is larger than 10, it's a 1. If X1 is not larger than 10, so 10 or less, it's going to be 0. What do I have down here for X1? It's 9, so that's less than 10, so this is going to be a 0. Okay. Now, we can come back above and recall that with our previous model, these same values, X1 is 9 and X2 is 11, the predicted value was 270.58. But now this is a new model that we've got, so I'm expecting it to probably be a little bit different at least. So let's just check it out though. And it says 270, it's the same. Oh, I know why. What did I do wrong? Well, I'm just looking here. I didn't give it the new model name. So let's M3, right? So I know I've got some advantages here in terms of looking at this, but I could see that this number didn't change. That was a tip off to me that I probably did something wrong. What did I do? I didn't change this model from M to M3. Now I have, so now let me run it. And it changes a little bit, right? Is it a big change? Maybe not. It goes from 278.58 to 271.13. Maybe not a huge change, but it did give me a different number. All right, so now I want to look at the output. So I can just say summary M3. I want to take a peek at that and see what I've got. Maybe I'm most interested in this indicator variable here. Is it statistically significant? No, it's not. P-value is 0.77. Suggests that this coefficient, we're not going to reject the hypothesis that it's 0, right? So it doesn't appear to have a big or meaningful impact here, right? But what does it do? It changes the intercept term, right? So the intercept term here, the 98.8. So when x1 is 10 or less, this indicator is 0, and this is the intercept term then, the 98.8. But if you want to think about other observations where x is greater than 10, then this indicator is 1. So we end up subtracting 5.687 from this intercept term, if you will, if you're thinking about graphing this out in a two-dimensional space. Okay, so then next point here is just to add an interaction term. I think that'll do it for us. So interaction term, let's go ahead and just copy in our model again. I'm just going to copy and paste here, so I'm not reinventing the wheel. And I want an interaction term, so I can do this with, there are a few different possibilities. I could do IND times x1 or IND times x2. Let's just use x2 as an example here. So this means the slope of x2 can differ. There can be a slope for x2 when the indicator is 0. That would be just this. And then when the indicator is 1, excuse me, then the slope changes by the coefficient on this interaction term. Let's just run this and then get the summary out for this and see what we have here. And again, we don't have much in the way of statistical significance, fairly large p-values on both the indicator and the interaction term, right? So we would fail to reject the hypothesis that the indicator, that this coefficient on the indicator variable is 0, and we would fail to reject the hypothesis that the coefficient on the interaction term is also 0. But at least that gets you started with seeing, again, how to create an indicator variable, create an interaction term, and run those regressions, and then at least get started with looking at the pieces of output there. So hopefully that's helpful, and take any questions you might have on the discussion board.